So in the last class we already did this type of things like a homogeneous differential equation. So in a homogeneous differential equation, we already did one problem, and also did something like suppose the differential equation is given in this way: dy by dx equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. So if a differential equation is given in this form, then it has two subcases. That means this type of problem can be solved in two ways. That can be solved in two ways. It has two subcases. So if your a by a dash is not equal to b by b dash, then we will put your x is equal to small x is equal to capital X plus s. Okay, I am writing these things. So already we did what is a homogeneous differential equation. Now I am saying special forms of homogeneous equations. Special forms of homogeneous differential equation. So in special form, if this equation is given in this way, like dy by dx is your ax plus by plus c divided by a dash x plus b dash y plus c dash. So if this is given in this way, then this form has two subcases. Like if your a by a dash is not equal to b by b dash, then this can be solved in some ways, and if a by a dash is equal to b by b dash, then this can be solved in a different ways. So if your a by a dash is not equal to b by b dash, at that time you will put small x equal to whatever the x and y are given, that is your small x small y. Okay, so you will put your small x equal to capital X plus h and your small y equal to capital Y plus k. Then this type of equation will be reduced to homogeneous form. Then after reducing it to homogeneous form, then we will apply separation of variable. Then separation of variables. And in this form, if a by a dash equal to b by b dash, then we will substitute z is equal to ax plus by. Then after substituting these things, then it will be solved by separation of variable method. Okay, now we'll go to this type of problems. If a by a dash not equal to b by b dash, and when a by a dash is equal to b by b dash, so suppose consider a problem. Problem 1. So solve dy by dx. Suppose your dy by dx is x plus y plus 4 whole divided by x minus y minus 6. So if a problem is given in this way, you just notice here a is equal to 1, the coefficient of x in the numerator. Similarly your b is 1 and c is equal to 4. And if you see what is your a dash, this is 1, and your b dash is minus 1, and your c dash is minus 6. Then what is your a by a dash? So here a by a dash is equal to 1 by 1, which is 1, and your b by b dash, which is your 1 by minus 1, which is minus 1. That means you can say your a by a dash is not equal to b by b dash. So put small x equal to capital X plus h and small y equal to capital Y plus k. So if your small x equal to this one, then if you will take derivative, then d of small x equal to d of capital X. Since s is constant, then its derivative is 0. Similarly, d of small y equal to d of capital Y, and derivative of k equal to 0. So if we will put these things in the given equation, suppose the given equation is equation 1. So now equation 1 becomes So now equation 1 becomes d capital Y by d capital X, because d small y equal to d capital Y and d small x equal to d capital X. So I will replace this thing here. Now d capital Y by d capital X is equal to x plus y plus 4. So in place of x I will put capital X plus h. Similarly in place of y I will put capital Y plus k, then plus 4. Similarly divided by capital X plus h, then capital Y minus k, then minus 6, and let this thing is equal to whatever the x and y, you will write only these terms. So this is your capital X and this is your capital Y, and in denominator this is your capital X and here capital Y is minus y. And assuming this constant terms equal to 0, that means assuming this h, what is your h plus k plus 4, h plus k plus 4 equal to 0, and in denominator h minus k minus 6 equal to 0. That means if I will assume this constant terms equal to 0, then only I will write the terms which involves this x and y. Okay, so now my dy by dx is x plus y divided by x minus y. Okay, which is a homogeneous differential equation. That means what is your dy by dx? This thing is equal to x plus y and x minus y. So which is a homogeneous differential equation? Which is a homogeneous differential equation? Because what is given first, that was not a homogeneous differential equation. Now I am reduced the given equation into a homogeneous differential equation. So if I will again remind you what is a homogeneous differential equation, dy by dx, for those students who didn't attend my last lecture, so dy by dx equal to m of xy divided by n of xy. So this thing is homogeneous. This, since a derivative is involved here, so I will tell you this homogeneous this thing as a homogeneous differential equation if both m of xy and n of xy are homogeneous functions of same degree. Homogeneous functions of same degree. Here if you will check, dy by dx is your x plus y divided by x minus y. The numerator x plus y, this is a homogeneous function of degree 1. Similarly x minus y, this is a homogeneous function of degree 1. So both numerator and denominator are homogeneous functions of degree 1. That means homogeneous functions of same degree. That's why my dy by dx is said to be a homogeneous differential equation. So now it is reduced into a homogeneous differential equation. Then we know how to solve a homogeneous differential equation. So if you will have a homogeneous differential equation, then we know we will put your y equal to v into x. So if we will put y equal to v into x, then your d capital Y by dx, that means taking the derivative of both sides with respect to x, then dy by dx will be v, then derivative of x is 1 plus x into dv by dx. So if your y equal to this one, then your dy by dx is equal to this one. So now suppose this is your equation 2. So now equation 2 becomes, dy by, in place of dy by dx I will put v plus x into dv by dx. This thing is equal to x plus y, x plus, in place of y I will write vx. Similarly x minus vx. So taking x common, this will be 1 plus v, then taking x common, this is 1 minus v. So x can cancel out, then this will be 1 plus v divided by 1 minus v. So here v is here, so I can write it x into dv by dx. This thing equal to 1 plus v divided by 1 minus v minus v. So if we'll subtract this thing, so if we will subtract this thing, then your LCM is 1 minus b, then this is 1 plus b minus b plus b square. So this is the general subtraction. Then what will left? This is 1 plus b square divided by 1 minus b. So your x into dv by dx is this one. So I can separate the variable. That means in one side I will keep my v, the variable v, and in other side I will keep the variable x. So if I will take this right hand term into the left hand side, so what will be it? This will be 1 minus b divided by 1 plus b square, this thing into dv, and if I will take x into right hand side, this will be dx by x, just a cross multiplication. So I can write the left hand side in this way. This is 1 minus b divided by 1 plus b square, and which is in separation of variable form, because here the variables are separated. Separation of variable means nothing, just the variables are separated, because in one side here whole v variable is here, and in other side a whole x is there, which is a separation of variable form. So if it is in separation of variable form, so how we are solving that one? So in our lecture 1 we already told, this is just simply you have to integrate it. Just I will separate this thing such that it will easily integrable. So this I can write 1 minus b by 1 plus b square as 1 divided by 1 plus b square minus b divided by 1 plus b square into dv equal to dx by x. So now I am integrating both sides. So now if we are integrating both sides, we get, so what we will get? So if we will integrate both sides, then you will see the integration of 1 by 1 plus b square, this is your tan inverse of v. Similarly, integration of v divided by 1 plus b square. So I will multiply 2 and divided by 2. So the divided by 2 is your half, and if you will multiply 2, then this will be 2v divided by 1 plus v square. That means in rough, if I will write this thing, what is the integration of v divided by 1 plus v square dv? I will multiply half, then divide by also 2, I will multiply 2 and divided by 2, then 1 plus v square dv. So this is your half, and the integration of this thing is your ln of 1 plus v square, only this thing. Okay, this is half ln 1 plus v square, so minus is here, so minus of ln 1 plus v square, and on the right hand side integration of dx by x is your ln x, then add the constant c. So your tan inverse v equal to ln x, then half ln 1 plus v square plus c, and you know what is your v? Your y is equal to vx. This implies your v is equal to y by x, and whatever the y and x, these are in capital X and capital Y. So from the above equation, here say h plus k plus 4 equal to 0 and h minus k plus here h plus k plus 4 equal to 0 and h minus k minus 6 equal to 0, and you have to find what is the values of h and k. So if your h plus k plus 4 equal to 0 and h minus k minus 6 equal to 0, so if we will add both the things, so after adding, so your 2h k will cancel out, k minus k, so your 2h minus 2 equal to 0, this implies your h is equal to 2 by 2, that is your 1. So if you will put your h equal to 1 in any of these equation, then what we will get? So 1 plus k plus 4 equal to 0, then your k is minus 5. So I am getting here h is equal to 1 and k equal to minus 5. So if your h equal to this one, k equal to this one, then what will be your small x? Your small x is your capital X plus h, so capital X plus 1, and your small y is capital Y plus k, so this will be capital Y minus 5. Okay, your small x is this one and small y is this one. So if I will put these things here, that means in tan inverse v means tan inverse of y by x. So tan inverse of this is capital Y by capital X. So this is ln, whatever I am writing, this is capital X. No, this one, this is your capital X, then ln capital X plus half ln 1 plus your v is y by x, so v square is capital Y square by capital X square plus c. And I already told you this x is this one, y is this one, and this is in small xy. So if I will replace, so what will be your capital X? So your capital, in place of capital X, I can write this is x minus 1 and your capital Y is small y plus 5. So I can replace capital X and capital Y by these formulas or these values. So what I will write, this is tan inverse of capital Y by capital X, that is your y plus 5 divided by x minus 1. Similarly ln x, x is your small x minus 1 plus half times ln 1 plus y square by x square, your y is small y plus 5 square divided by x minus 1 square. So this is your that is plus c. So this is your answer, because the question is given in small y and small x form. So now we reduce this thing in small x and small y form. All the answers are in small x and small y. Okay, so that is your answer. If you will simplify, then you can go to one line more. This thing ln a plus ln b, this is your ln ab. That means the right hand side I can simplify. This is ln of x minus 1. This is ln of x minus 1, and this thing is half. So this is 1 plus y plus 5 whole square divided by x minus 1 whole square whole to the power half plus c. So if you will simplify, this is ln x minus 1 and you just add it. This is x minus 1 square, then x minus 1 whole square plus y plus 5 whole square whole to the power half. So whole to the power half, then plus c. So this will be ln so this x minus 1 and this is x minus 1, this thing cancel out because there is a square root. So a square root of numerator by denominator means this is the square root of numerator and square root of denominator. That means this thing and this thing will cancel out. So only thing left is this is x minus 1 whole square plus y plus 5 whole square, then it's square root plus c, and your left hand side is your tan inverse of y plus 5 divided by x minus 1. So if you simplify, then you will go to this step. So this is your answer. Okay, so if a differential equation is given in the another form, suppose the dy by dx, this is another problem. So if your dy by dx is x plus y plus 4, x plus y plus 4 divided by x plus y minus 6. So if a differential equation is given in this way, if you will see here, a is equal to 1, b is equal to 1, c is equal to 4. Similarly, a dash equal to 1, b dash equal to -1 and c dash equal to -6. So if you will observe your a by a dash, this is your 1 by 1, that means 1, and b by b dash, this is also a by a dash is 1. Similarly b by b dash, this is x plus y plus 6, x plus y plus 6. So here b dash is plus 1, so b by b dash, this is also 1 by 1 equal to 1, that means your a by a dash is equal to your b by b dash. So if both these things are equal, then what we will do, then put z is equal to this x plus by, that means your x plus y. So if z is equal to this thing, so your dz by dx, this will be 1 plus dy by dx. Now I will write what will be my dy by dx, because I will replace here, this is my given equation, let it be equation 1. So your dy by dx, this is your dz by dx minus 1. So now equation 1 becomes, in place of dy by dx, I will put dz by dx minus 1, then this one z plus 4 divided by z minus 6, z plus 4 divided by z minus 6. So what will be this one, this is your dz divided by dx, and here the minus 1 will go to right hand side, then this will be z plus 4 divided by z minus 6 plus 1, which is LCM is z minus 6, then this is z plus 4 plus z minus 6, which will be your 2z minus 2 divided by z minus 6. So here dz by dx equal to this thing. So if I will put these things into left hand side, that will be your z minus 6 divided by 2z minus 2, z minus 6 divided by 2z minus 2 dz, and the right hand side is only dx, which is a separation variable form, or which is in separation of variable form, okay, because in one side here is whole variable z, and in another side here whole variable x. So we are able to make the separation of these variables. So now if we will take its integration, so how we will take in the integration, okay, also you can write this thing here. If you will take, this is 2 times z minus 1 divided by z minus 6, so I can write here, this is z minus 6 divided by z minus 1, and I will keep the 2 there, okay. So I can write this thing as, this z minus 6 by z minus 1 as, you know how to integrate this thing, so I can write this thing as z minus 1 minus 5 divided by z minus 1 into dz equal to 2 times dx. This implies z minus 1 by z minus 1, this will be 1. So z minus 1 by z minus 1, this will be 1, then only left is 5 divided by z minus 1, this thing into dz equal to 2 dx. So now integrating both sides. So now if you will integrating both sides, then what you will get, the left hand side's integration 1 into dx is your, 1 into dz is your z, then minus 5 times integration of dz divided by z minus 1, this is your ln z minus 1, right hand side is 2x plus some constant. So your z, you can replace z, your z is x plus y, so now in place of z you can put here x plus y minus 5 times ln x plus y minus 1 mod is equal to 2x plus c. So you can say this is your answer. Okay, so if any equation is given in this form, this is in which form? This is a form which can be, this is not a this is just an application of homogeneous differential equation. This thing can be said as special forms of homogeneous differential equation. This dy by dx equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. Okay, now these two forms are solved. So now we'll go to next, exact differential equation. So what do we mean by exact differential equation? So you can say this is your method 3. In method 1, we read the separation variable form. In method 2, so we already know your method 1, which is a separation of variable form or separation of variable, and in method 2 we know what is how to solve a homogeneous differential equation. This is how to solve a separation of variable form. Now in method 3 we will solve how to solve a exact differential equation. That means if a differential equation is exact, how to solve it. So method 3 is your exact differential equation. So what do we mean by exact differential equation? So now first come towards definition. A differential equation is said to be exact, or we can say a differential equation m of xy dx plus n of xy dy equal to 0 is said to be exact, if there exists a function, u of xy such that d of u of xy, this is your m of xy dx plus n of xy dy. Okay, so if any differential equation is given in this way, this differential equation is said to be exact if there exists a function u of xy such that derivative of u of xy equal to this one. So if this thing happens, then this is a exact differential equation. And you know, we are studying this thing first order first degree differential equation. This is the, what is the chapter name? This is first order and first degree. And you know what is the general form of first order first degree? This is your dy by dx, because its order is 1, degree is 1, dy by dx equal to f of xy. So if any equation is given in this way, then you can reduce it into this way, then you can say about its exactness or something. So if it is given in the starting, if it is given in this way, it is okay. If it is given in this way, the standard form of first order first degree equation, then you will reduce it in this way. Then after reduction, this thing is said to be exact if there exists a function u of xy such that its derivative is equal to here given question. So there is also one more thing. If a differential equation is given, how you will say that it is exact or not? This is the definition of exact differential equation, but how to check it? So how to check if the differential equation is exact or not? So there is also a test for exactness. So what is that test? That means if the equation is in this form, or if it is from this form, you will reduce it into this form. So now I am writing only this form. If the equation is in m of xy dx plus n of xy dy equal to 0 form, then find del m by del y. This is the partial derivative of m with respect to y. If del m by del y equal to del n by del x, then suppose this is your equation 1, then equation 1 is said to be exact. So if equation 1 is given to you, then you have to check if del m by del y equal to del n by del x. So del m by del y means what? Here m is a function of xy, and del m by del y means this is the partial derivative of m with respect to y. And you know what is the partial derivative? That means I am treating this x as constant. Okay, if m of xy is given to you, suppose I will write a function here f of xy equal to 2x square y plus 3xy plus y square. Suppose this is a function. So what is my del m by del x? Del m by del x means this is a partial derivative, sorry, del f by del x. The function is f. So del f by del x means f is a function of xy. So now I am taking its partial derivative with respect to x, means you will treat this y as constant. In f of xy, whatever the values of whatever the y are there, you will treat y as constant. So if you will treat y as constant, now take the derivative of f, or take the partial derivative of f with respect to x. So I will treat y as constant. So with 2 I will write 2y, then derivative of x square is your 2x. Similarly there is 3xy, so I will write this constant 3y, then derivative of x is 1. Similarly derivative of y square, y is constant, so y square is constant, so its derivative is 0. So only del f by del x is your 4xy plus 3y. Similarly if I will calculate what is your del f by del y, so partial derivative with respect to y means other variables are constant. That means here the only variable was x, that was constant, you will treat as constant. So take the partial derivative of y, partial derivative of f with respect to y. Now 2x square behaves as constant. Okay, so 2x square is constant, so derivative of y is 1. Similarly there is 3xy, so you will write only 3x and derivative of y is 1. Similarly this is y square, and y square derivative is 2y. So this is all about the partial derivative with respect to x or with respect to y. So here you have to evaluate after finding what is your m of xy, the coefficient of dx is your m of xy, and the coefficient of dy, this is your n of xy. So if you will check your del m by del y equal to del n by del x, then if these two things are, or these two partial derivatives are equal, then you can say that the equation 1 is a exact differential equation, and since it is a exact differential equation, you can find a u of xy such that its derivative is this m of xy dx plus n of xy dy. So now come to its solution procedure. Suppose you will know that this equation 1 is exact. So I am saying after knowing that equation 1 is exact. So if you know here this equation 1 is exact, so how you will find this u of xy such that you can say its derivative is this one. That means if you take the integration of both sides, you will get your u of xy. So how you will find your u of xy? So if the equation 1 is exact, then the solution u of xy is equal to, so this is your solution, then the solution u of xy, this thing is equal to your integration of m of xy dx. Since I am taking the derivative with respect to x, taking integration with respect to x, so in this integration you will write treating y as constant, treating y as constant. Okay, similarly plus integration of n of xy dy. So here I can write for which term I will take my integration. here the nxy, I will take the integration of n of xy subject to the condition that only those terms which do not contain x, which do not contain x. Okay, you just remember this thing. If a differential equation is exact, this is the way to check whether that differential equation is exact or not. If that thing is exact, then this is the method of, or this is the formula for finding its solution. So u of xy is its solution, and u of xy can be evaluated in this way. Integration of m of xy dx treating y as constant plus integration of n of xy dy only those terms which do not contain x. So now come to a problem. Suppose a equation is given. Suppose a problem is given to you. Let that be. Solve the differential equation, and the differential equation is y cos x plus sin y plus y dx plus sin x plus x cos y plus x dy equal to 0. So again let's check it. Y cos x plus sin y plus y whole dx plus sin x plus x cos y plus x equal to 0 plus x dy equal to 0. Suppose this is the problem is given to you. So how to find its solution? So if the problem is this one, then what is your m of xy and n of xy? Here m of xy, this is the coefficient of dx, so your m of xy is y cos x plus sin y plus y. Similarly, your n of xy is your sin x plus x cos y plus x. So this is your m of xy and this is your n of xy. So now I will check my exactness. Now I will calculate what is my del m by del y. So m of xy is your this one. So what is the partial derivative of m with respect to y? So you know, while I am taking the partial derivative with respect to y, I will treat x as constant. So this will be cos x and derivative of y is 1. Similarly, this is whole sin y and the derivative of sin y with respect to y is your cos y. Similarly, this is y and derivative of y with respect to y is 1. Similarly, what will be your del n by del x? This is your del n by del x. This is sin x and its derivative with respect to x is your cos x. Similarly, this is x cos y. Since I am taking partial derivative with respect to x, so I will treat this y as constant. That means cos y is constant and derivative of x is 1. So into 1, or you can, okay. So derivative of x is 1. So if you will see, this is cos x plus cos y plus 1. This is cos x plus cos y plus 1. So here del m by del y equal to del n by del x. That means so this thing, these two things are equal. So the above differential equation is exact differential equation. That means the equation 1 is exact. That means equation 1 is exact. So if equation 1 is exact, then how we will find the solution? Then the solution is given by so I already told you what is the solution. Let the solution be uxy. Then the solution uxy is given as, this is the integration of m of xy dx treating y as constant, plus integration of n of xy dy only those terms which do not contain x, So now what will be your u of xy? So what will be your u of xy? This is the integration of m of xy dx. So where is your m of xy? Your m of xy is y cos x plus sin y plus y. This is your m of xy, and I will write this thing treating y as constant. Treating y as constant plus integration of n of xy, and what is your n of xy? This is your sin x plus x cos y plus x plus x. So this is your n of xy, and here what I will write below the integration, only those terms which do not contain x, So how we will take the integration of this one? This is y cos x plus sin y plus y. Hello, no sir जाओ क्लास सारी के जाओ 10 मिनट रे. हाँ सर पर कथा होचे. हाँ तो आम जदि यार इंटीग्रेशन काढ़ा कौन हम सॉरी इंटीग्रेशन ऑफ दिस वन with respect to x we will calculate it treating y as constant. So if you will take its integration, suppose for first term, what is the integration of this first term treating y as constant? So y will go to outside of this integration, then integration of cos x is your integration of cos x, this is just sin x. So integration cos x is sin x. Similarly then I will find the integration of sin y. So integration of sin y treating y here in this above integration I am taking y as constant, so sin y can go to outside of this integration, then only integration of dx will be left. So integration of dx is x, then this is y can go to outside the integration, then integration of only dx will be left. So integration of dx is x. Okay, that means you have to treat y as constant. Then so you can take that constant outside of that integration, then you just write down what is after taking y as y outside the integration, then what is the integration, you will just write it. Similarly here you have to integrate this thing. Okay, you have to integrate this thing only those terms which do not contain x. So this is a term which contains x, this is also a term which contains x. So in all these terms contains x, so only those terms which do not contain x, so I can write only 0 into dx, because in every term there is a x. Okay, so I have to integrate only those terms which do not contain x, so only 0 will be left. So 0 dx, so integration of 0 means this thing will give you 0, so only this thing left. So this is your u of xy is equal to y sin x plus sin y x plus xy. So this will be your answer, or plus some constant c. So this is the answer, y sin x plus sin x sin y plus xy plus some constant. So this is your answer. So in this way, if any differential equation is given, then you can check whether it is exact or not. If del m by del y equal to del n by del x, then this is exact. So if it is exact, then this is the way to find the solution. That means your u of xy is integration of m of xy dx plus integration of m of xy dx treating y as constant, and this one integration of n of xy dy only those terms which do not contain x. Okay, so